everyone, I'm Cassandra Pauline B. Cabrera, a grade 9 student from the Philippines, and this is my entry for the World Mathematics Invitational 2026 Mini Math Creative Competition. Now, imagine a world without geometry. There would be no towering pyramids, no majestic domes, no breathtaking palaces, and no futuristic skyscrapers. The buildings around us won't just lose their beauty, they might just stop standing too. Behind every architectural masterpiece is a hidden language of shapes, patterns, angles, and proportions. That language is geometry. Today, I'll be taking you across the world to witness six remarkable structures from Egypt to Italy to India to Spain to France and to England and discover how geometry has shaped the world we live in. Our journey begins over 4,000 years ago in Egypt. Rising from the desert sands stands the Great Pyramid of Giza. At first glance, it may seem simple, a square base and four triangular faces. But this simplicity is precisely what makes it extraordinary. At its core, the Great Pyramid is a geometric solid with a square base and four congruent triangular faces. Architects and historians have long studied its proportions. Each face forms an isosceles triangle, and the pyramid shape can be analyzed using right triangles. When engineers calculate the slant height of a pyramid, they use the relationship between height, half the base length, and the slant edge. This is recognized as the Pythagorean theorem. The pyramid's geometric form distributes weight evenly toward the ground, creating remarkable stability. Its precise alignment and symmetrical design helped it withstand earthquakes, storms, and the passage of time. Thousands of years later, it still stands. The ancient Egyptians may not have had computers, but they understood a timeless truth. Geometry creates strength. As civilizations advanced, geometry became more than a tool for stability. It became a tool for innovation. In Rome, around 2000 years ago, architects constructed the Pantheon. Unlike the sharp angles of the pyramid, the Pantheon celebrates curves. Its massive dome is based on the geometry of a sphere. In fact, if you could place a giant sphere inside the building, it would nearly fit perfectly. This careful geometric design allows forces to spread evenly throughout the structure. The result is one of the greatest engineering achievements of the ancient world. Geometry transforms stone and concrete into something that almost feels weightless. But architecture is not only about strength, it is also about beauty. In India stands the Taj Mahal, one of the most admired buildings on earth. Its secret lies in symmetry. The left mirrors the right, the front mirrors the back. Every element appears balanced and harmonious. Some researchers connect these proportions to the golden ratio. The golden ratio appears throughout art, nature, and architecture because it creates shapes that many people find aesthetically pleasing because our brains are drawn to order and pattern. Through precise geometric planning, architects created a structure that feels calm, elegant, and timeless. Here, geometry becomes art. If geometry can create beauty, can it also create wonder? The answer lies within the Alhambra in Spain. Its walls are covered with intricate geometric patterns known as tessellations. A tessellation is a pattern of shapes that fit together perfectly without gaps or overlaps. Triangles, squares, and hexagons, repeated again and again. The result is a mesmerizing display of mathematics transformed into decoration. Long before modern mathematicians studied these patterns in depth, artists and architects were already using them to create breathtaking works of art. In the Alhambra, geometry becomes a masterpiece. Thousands of years after the Great Pyramid of Giza was built, architects returned to one of humanity's oldest geometric forms, the pyramid. In Paris, the Louvre Pyramid combines ancient geometry with modern materials. Designed using hundreds of triangular glass panels, it demonstrates how timeless geometric principles can be adapted for a new age. The same shape that once symbolized ancient Egypt now welcomes millions of visitors to one of the world's most famous museums. Geometry connects the past and the present. Today, geometry continues to evolve. In London, the Gherkin skyscraper showcases how modern technology allows architects to explore entirely new forms. Unlike traditional buildings, its curved surface was created through advanced geometric modeling. Its shape is not only visually striking, it also improves airflow and energy efficiency. Here, geometry is no longer limited to simple triangles and circles. With the help of computers, architects can design structures that once seemed impossible. Geometry is shaping the future before our eyes. Geometry has guided architecture for thousands of years. It provides strength, it inspires beauty, it fuels innovation. And although many people see buildings as collections of stone, glass, or steel, architects see it as something more. They see lines, angles, patterns, and shapes. Because behind every great structure lies the same hidden language, a language that has endured for centuries, a language that continues to shape our world. That language is geometry. Geometry is not merely mathematics, it is the foundation upon which civilizations are built. Again, this has been Cassandra Pauline B. Cabrera, a grade 9 student from the Philippines, and this is my entry for the World Mathematics Invitational 2026 Mini Math Creative Competition. Thank you!